Let's tackle the case to see what happens when both supply and demand are going to shift at the same exact time or simultaneously. And the easiest way to deal with this is just to go ahead and tackle each of the shifts one by one. So shift out supply in the appropriate direction, shift out demand in the appropriate direction, then find out where your new intersection is going to be in order to find your new equilibrium price and new equilibrium quantity. And in this particular example, we're always going to go ahead and say that at least one of the shifts affects supply and the other shift is going to affect demand. So we will not double up on our shifts. So both shifts won't affect demand, both shifts won't affect supply. One will always affect supply, one will always affect demand. So do be aware of that as you work through these examples right here. So suppose that I tell you that both supply and demand are going to increase. So you go ahead and follow the methodology that we laid out. First, you draw out your supply curve. You're going to say increase. You're going to shift it away from the origin. You draw it out as such. And then you go ahead and draw out your demand curve increasing away from the origin as well. So here, where's our new equilibrium intersection going to lie? This is once again why we label out our curves, S1 and D1. The new intersection between supply and demand is going to be exactly right here. And this is our new equilibrium point. And from this, we can find out what happens to our new equilibrium quantity and equilibrium price. We know for sure equilibrium quantity has increased. It goes from Q0 to Q1. We know that for sure. But what happens to our equilibrium price? Before, initially, we had an equilibrium price of P0, but it looks like it's the same exact P0 with our new intersection. And this is always going to be the case anytime we have equal magnitude shifts. At least one of our variables, either price or quantity, is always going to stay the same or indeterminate, as they formally call it, anytime we have equal magnitude shifts. Equal magnitude shifts just tells us that we're drawing out supply and demand in the same exact ratio or length. You notice that when we drew out the supply and demand shifts, they're the same exact ratio. So anytime this is going to be true, we're going to notice that at least one of our variables is going to be unknown, indeterminate, or staying the same. So that's kind of important for us to note in this sort of section. So let's go ahead and write that down for your notes. So with equal magnitude shifts, at least one of our variables is always going to be the same, indeterminate, or unknown. They're all synonymous terms with one another. So when prices or quantity are the same, that also means that they are indeterminate or unknown. Indeterminate or unknown. So once again, these are all synonymous terms with another, saying the same, indeterminate, unknown. They mean the same exact thing for us. However, it doesn't always have to be the case where we have symmetric shifts. So supply and demand don't always have to be symmetrically shifted with one another. So what happens if the problem actually tells you that, hey, what happens if the shift in demand is larger or smaller than the supply shift? Then in order to find out what happens with our new equilibrium, we just need to go ahead and draw it out. And don't worry, the problems will always tell you whether or not these are going to be symmetric shifts, they're of equal magnitude, or if they're asymmetric shifts. So let's go ahead and tackle the case if the demand shift is larger than the supply shift. If the demand shift is larger than the supply shift. So we'll tackle this problem right here. So here we have demand increasing, we have supply increasing, so just following the same problem that was laid out on the slide, but we now want to make sure that the demand shift is larger than the supply shift. And you're basically just going to go ahead and draw this out as such. So let's go ahead and build up to see what happens with our equilibrium. Is something going to be different compared to the equal magnitude shifts? We have price, we have quantity, we have supply and demand. We have D0, S0, and we're just going to go ahead and say this point right here, point A, this is going to be our initial equilibrium. So just label everything out as much as we can. P0, Q0. So once again, we want to see how this is going to be different compared to the equal magnitude shift case. So go ahead, follow the problem out. Demand is going to increase, but we want to draw this demand shift out as large as we can. The more extreme that you make these sort of shifts, the easier it's going to be to see what happens in equilibrium. So demand increasing, we're going to draw out our demand curve, say, hey, it's going to be a very huge shift. We have D1 in this instance. So pretty much the same that we saw in the slide before. However, we want to go ahead and match up with what we have right here, where the supply shift is going to be smaller than the demand shift. Our supply is still going to increase, but it's not going to be as big as this ratio right here from the demand shift. So we can just draw, hey, maybe just a very small shift right here in order to match up with what the problem is telling us to do. So with this, what do we notice about this particular equilibrium now? We notice that we've successfully drew out as the problem told us to do. The demand shift is much larger than the supply shift. So where's our new equilibrium going to lie? So S1, D1, find that new intersection. It's going to be right here, this red line and the white line. It's going to be our point B. That is where our new intersection is going to be. But with this, what happens to our equilibrium quantity? So equilibrium quantity, yes, it's still going to be increasing as before. So yes, we do know that we have a higher quantity. That's the same as before with the symmetric case. But what happens with the price? We notice that as we bring this all the way to our price axis, it's higher than P0, so we have a higher price as well. So higher price. So anytime we have these asymmetric shifts, we will know for sure what happens to our equilibrium price and equilibrium quantity. There is no indeterminacy, there is no unknown. So here, we do want to be very careful with these symmetric versus asymmetric shifts because your answer will change depending on what happens with each of the relative magnitudes of the shifts. So once again, the easiest way to build this up is to go ahead, draw out these curves, and then draw them out as the problem details to you. The problems, once again, will tell you specifically, explicitly, whether or not these are symmetric or asymmetric shifts. So you guys want to go ahead and get a lot of practice with these type of simultaneous shifts. You will face a lot of them in your practice problems. We'll do an assignment on this very, very shortly. So be sure that you understand these simultaneous shifts because they are a huge part of economics and we will see them throughout the rest of the semester. We'll do a little bit more practice in the last video.